Hi. In the previous tutorials we have been creating a simple number guessing game, and we will continue to expand on that application. Today we are going to implement command line arguments using the std.getopt module, and we will move these parameters to runtime and let the user configure them when launching the application. If you're unfamiliar with getopt, it is options sent to processes when you start them. So the basic syntax is for the help. You see I wrote help up here, and you'll see how to launch the application, some information about what the application does, and then a list of arguments. And you can specify a short version that is very usable, that is very convenient when you are using the command line launching applications, and a long version that you can use from scripts when you need a bit more descriptive texts. So you see all arguments with some information about what they do, and you see also our DMD compiler also includes a file like this, and the same with RDMD and dub. So it's pretty common to allow runtime arguments. Before we do this though, I discovered a bug in the previous tutorial, and I can show the bug. The problem is that we get 4 tries rather than 3. And the reason for this, we have our max tries up here set to 3, but we read the input before we see if it is finished. So the first time we have 3 tries, and we read the input and we decrement and so on, and the last time we have 0 tries left, but we still read the input and then break. So we could solve this by moving the tries left up here before reading the inputs, but I'd like to keep this logic where I just have a simple if-else-if list down here with a control flow at the end of each. So the simple fix would just be to loop one less time, and we now have 3 tries only. Back to the getopts, I have prepared a little help file. It should be possible to do this automatically from the module generating this file, but as of the time being it's not, so I've written this by hand, and I'll duplicate some of the information like default values between here and the source code. So these are the options I've been thinking of adding: overriding what the answers should be, specifying minimum and maximum values, printing the answer, max tries, and the prompt for guessing. We'll start by changing these 3 variables. For one, we cannot longer use enum because it's only available at compile time. We can say auto instead, and we'll need to import our module. And we also need to say that we are accepting the arguments from the command line. So let's see what this args will contain first. So let's just print it out, compile the application, and you see at the top here that it includes the file name for the application, and this will always be true. The first argument is always the name of the application. But let's test with something else here, and you see we will get an array with all the arguments as different elements, and space will separate them. So we start by saying that we should run the getopt method on the arguments, and the getopt method will parse the arguments, and then it will parse them given our specification. So let's start by adding the min value. And you'll see here that the first argument is the arguments that are passed into the application. And then we have a list of argument pairs. So let's do it like this instead. So every second argument should be a new value, and we specify the name of the long option, and then we specify the variable that we wish to set. And getopt will understand, or it will look at the type of the variable we are passing in, and it will see that it's an integer, and thus requiring the argument to be of type integer, and it has some logic on what the argument might look like. So let's first compile this application and then try it out. So we specify the min value, and we say -52, and you see that it will use this value. Or we can say max value 52, and it will also go up to 52. So you notice that when using integer values, we can specify it with a space or an equals. And getopt will now also enforce us to use only valid options. So we'll get an error if we try to use an option that isn't valid. So if it's not an integer, or we are specifying an option that doesn't exist, we will get an error. Of course, these aren't, we don't want to give the user a stack trace for this, so we'll have to fix that later on. So we are adding our last value here, max tries. So now we are using these default values, and we are allowing the user to override the values here. So I also noticed, or I also said in the help file, that the values must be correct. So you cannot have we cannot have a min value greater than a max value, and so on. So we'll need to add this to our application. Good starting point here would be to refactor the code and do the validation in a separate method or function, but to keep it simple right now, we'll just do the validation here. So let's start by renaming these variables. I'm not very fond of using uppercase values for, well, it's not constants. And we also have the max tries here. So we'll first check that min value is less than max value. And we'll write an error if it's not, or if it is greater. Min cannot be greater than max. And then we need to exit the application. And the reason why I'm using exit here is to return an error code from our application. So scripts running the program won't think that the application has succeeded. And I'm using a hard-coded value for now, 1 for invalid arguments. And this exit function is available in this module. And I'm using exit rather than changing the return type of main to int. And this is because I plan to just push all the validation into a separate function and exit the application rather than returning if it's a success or similar. Next we can validate that max try is greater than 0. So if it's less than 0, then we won't ever run the application. So we can use the correct names here. Min value, max value. So let's test if our application is working. Compile it, and min value setting it greater than max value gives an error, and setting max tries to 0 also fails. And you notice that we are using WriteLine as we have used many times before, but WriteLine defaults to writing on the standard input and writing it to the standard output, sorry. But writing it to the standard output should be for regular application output. These are error messages. So the first parameter could be standard error. So this means that use the standard error file descriptor to write this to write this message. So that way we could or the user can redirect the output for errors to not see them, or they can write them to a log file or something like that. Next up we have this debug statement that we now wish to allow the user to specify that it should be written from the command line. So we are going to use a Boolean operator. So we can call this do print answer, and we should default it to false. Default to false. Print answer. And if do print answer, then right line. And you see here we don't check that if it's equals to true, because if a variable is equals to true, or if it is non-zero, or if it's a reference and it's non-null, then this is true. So let's test our application now and see if it's working as expected. So just running the application, then it's default no don't print the answer. Let's test min value and print answer, and you see that we get the answer printed out. And notice that we didn't have to specify true. We can do this, and we can specify false, but when getopt encounters a Boolean variable, it will set it to true just by adding it to the command line. Next up, let's see, we can implement this prompt, and you see this is the first option that we want to use a short value for also. So let's implement this one, and we have the prompt, and then we can specify this bar symbol and then P for the prompt. So and again we can use auto for a value. And we need to change the prompt, and that is in here. So we need to also specify it at the command line. As the arguments. Okay, let's see if this works. Compile the application. And let's try running it with some custom value with the long version, and then with the short version. And as with the integers, you can also use space in addition to equals. And now let's implement our help screen. So we'll pass this directly to a function. So we'll implement a new function, print help, that will only write the help screen and then exit. So the usual way to print the contents of a file is to open it and then print it after you read the lines or read the entire text or something like that. But if you have a file that is known as at compile time, you can use a different way in D, that is a file import. So this will import the contents of this file directly as it looks, and this way you can add binary blobs into your files, or you can parse files at compile time. So it's a convenient thing for static files that doesn't change. So there is no runtime overhead in doing this. It's added as is to your file. So we know how exits several places. We'll add the import to the top. And now we need to, if you look at the bottom of the screen, need -j path switch to import text file. So this is a security measure of the compiler, that's so that no one is able to override what gets pushed into your file. So this could have been code that is executed at compile time that you are mixing into D and running directly. So you don't want someone to change the behavior of your application by just fixing paths in the system. And to add this, you need to add the string import paths. I already did this. So this tells dub that the current directory should be passed as the -j switch to the compiler, so that the compiler finds the file and compiles it in. So we'll build the application and try to run it with a -h switch, and you see we get the help screen. And this will now happen even if we specify other arguments, because if it encounters a help switch, we call our custom method and we do an exit in it. So this might not be the behavior you want, so you might have to remove the exit and check if help has been set and just continue anyway, or whatever the semantics you wish are. So let's implement our final command line switch, setting the answer. This is going to be a bit more complicated. We need to first check, we need to run the code after the min and max value has been set. And we don't want to generate the answer if the value has been set. So there's a couple of issues here that we need to resolve. So to do this, we will implement an inner function that will look at the variables in the outer scope. So So let's look at this. This is a regular function, but defined within main. So this function will have access to these variables on the top. So it can see the variables and it can set the variables. So this is our regular answer variable, and we'll use this to see if we have set the variable from the command line. And we'll use this as a handler function for getopt. So this will be called if the answer is seen at the command line. And getopt requires the arguments to be first the option string, because you can use the same handler for many different options, and then the parameters. So it will understand that it's an integer parameter. So if getopt sees the answer, we will set the answer to be our custom answer supplied on the command line, and we'll set that it has a custom answer from the user, and this is to avoid generating the random value. So generating a random value is an expensive call, and we don't want to call that function unless it's necessary, and it isn't if we set it on a command line. So let's see, I have a bug here, custom answer. There. Trying to compile the application now gives an error. I had to look up the documentation because it getopt doesn't understand that it's an integer, so it requires the argument to be of type string. So we'll need to convert it to an integer ourselves. So answer already defined, and that is done here. So after we have read the options, min and max value have been set, and our answer might also have been set. So if it has if it doesn't have a custom answer, then we will generate it. But the application now has a bug because we're not validating the answer, so we cannot specify we cannot complete the game if we specify an answer outside of the range, so we'll need to validate the answer. So if it's outside the range, we'll say that it must be within the range. So that's working. And now we have implemented all the values, I think. So let's refactor the application a bit, because now we have some temporaries here that's only used for the command line parsing, and we'll move all this handling to a custom function. So let's start by just extracting everything. But we also need to be able to get all these values within our main function. So we need do print answer, min max answer, every one of these variables. And to get these variables here, we'll add them within a custom struct. So we'll create a new type, we'll call it settings, and then we'll add all these values here with the same defaults. Let's just copy it and do print and guess. And we now need to, we can either create the settings in here and return it, or we could allow it to be passed in to the handle arguments. So let's do this so that the user of this function can specify some or override some of the default values we have set here before parsing the arguments. And you notice that I specified ref, and this allows a value type to be passed by reference, so that no copying is done by the compiler. So a struct is a value type, so that if we just pass in settings, this type, then it will be copied. So every one of these values will be copied into the handle arguments function. So we'll specify ref so we can avoid the copying here. And now let's fix these to use for settings. And we need the settings.answer here. And we need the settings.min and max and settings.try. I should have done some edit replace. Okay, let's see if this was everything. Let's see where this error is happening. Line 47. Okay, and here we are copying in the values, and getopt are saying that it won't work on that. It needs a pointer, and we'll fix that by passing in the address of the variables rather than copying it into getopt. And some other errors here while refactoring. And we are missing our do print answer. Print answer false. So let's test that. And it seems like it's working. So let's just clean up this. And we might also split up this function to validate the arguments another place, but this is still a pretty simple function, so we'll keep it as it is. Okay, this is starting to become a quite long tutorial, so I think we'll stop there. So this was some simple argument handling with std.getopt, and hopefully it will be a bit clearer how to create this. Okay, thanks, bye.